So in my hand are proteins. Proteins are actually everywhere in my hand, but not only my hand. They're also in every single other part of my body. So what these proteins actually do is, for example, form collagen in my hand. But sometimes these proteins can get a little faulty. And this is often due to mutations. So while most of these mutations are harmless, or maybe they can only cause some minor changes within these proteins, sometimes these kind of mutations can actually completely alter what these proteins are actually supposed to do. So for example, in a certain collagen mutation, this can lead to more brittle bones or maybe more fragile connective tissue. So what I actually wanted to see was the difference between a normal protein and a completely edited mutated version of this protein. So in this case, I used PyMOL and AlphaFold to import a model of a p53 protein and see how a specific amino acid change within the gene can completely change how this protein actually works. So in this case, I looked at the ARG249 SCR mutation in this gene, which is mainly associated with liver cancer. The p53 protein plays a really important role in preventing cancer by regulating cell division and also promoting DNA repair. So what essentially happens when ARG or arginine mutates into SER or serine at position 249 in the TP53 gene, which is what produces p53 proteins, what essentially will happen is instead of doing their normal job, now these proteins are told to do something different. And these changes will likely lead to uncontrolled cell growth, which actually can influence cancer later on. The model will also be a really simplified version of the p53 protein in real life, but it will still show some of the main key components of what is actually included in the protein. So I actually realized that making this model on PyMOL was actually really easy, and it actually only took me a couple of steps. Okay, to start, first we want to import a PDB file of the p53 protein. So I found one on AlphaFold, so that's the one that we can use for today. Okay, so here is actually a model of a p53 protein. And it's actually really nice because, as you can see, it's really easy to see all of the residues in the protein. Also, they are residues because when amino acids are essentially copied into proteins, then they kind of like lose something, so then they essentially become residues. So that's really important because PyMOL calls them residues. What we want to find is one specific residue. So to do this, all we have to do is select Resi 249, because residue 249 is what we want to find in this case. Okay, so now we can actually see that it found residue 249, but it's kind of invisible. It's kind of in dot form. So what we need to do now is actually convert it into stick form. So to do this, we can type in show sticks resi 249. But to actually distinct it from the rest of the residues, now finally we can just color it a random color. So in my case, I'm going to color it red. Okay, so now it's really easy to separate this specific residue from all of these other residues in the protein. And this is actually really important for the next step where we have to edit it. What we want to do now is convert this specific residue from ARG into SCR. So as you can see, I actually pulled out the sequence, so you can see up here the changes. It also will happen specifically at this location. Now to convert this, all we have to do is now type in wizard mutagenesis. Okay, so now you can see that the mutagenesis wizard is now open, and you can see there's a couple of options here. But for now, all we really want to do is mutate it. So all you have to do is click on no mutation, and then you can just scroll down. You'll eventually find SCR. Then, to actually apply the changes, then you just click apply. Okay, so now we can actually see that if we click apply again, that will actually turn into SCR. So if we now click apply, now we can see that it's S in replace to R. Out of all of these, there's a couple of possibilities, and we want to choose the possibility with the least number of clashes possible. So to do this, you can just go into global frame, see all the options. As you can see, 3 has a lot of clashes, so we do not actually want this. We want the best possible option. So it seems like 2 is the best one. And then all we have to do to finally finish this off is to just click apply. Okay, so now what we want to do is see all of the other residues around this newly inputted SCR residue, and then ultimately refine the structure and also remove any other existing clashes around it. So to do this, first we need to select it, then go to A, then modify, expand by 5A. So essentially this is letting you select all the residues around this SCR residue, and to actually show them, then you can go into show sticks. So now you can actually see all of the residues around it in stick form. And now to actually refine the structure, then we can go into A, then press clean. So now as you can see, it kind of edited the structure a little bit. And all the residues around it kind of moved a little. So now what we want to do is then go into hide, and then hide all of the sticks. And then we want to go click this again, show sticks. So what that just did is just hide all of the other existing residues around it again. So if you noticed it a little, it kind of moved a little to the right, and this ultimately helped remove all the clashes around it. Okay, so from this project, I kind of learned how mutations can happen and how mutations can necessarily affect a protein. And I also got a lot of experience with working with PyMOL, which is a website I never actually used prior to this project. So yeah, it was a pretty fun way of learning how exactly residue changes can occur in proteins. Also, shout out to this channel for teaching me how to use PyMOL and also how to just stimulate mutations in the first place. Okay, so thanks for watching my video, and I hope you keep on watching more of my videos that are coming soon.